These notes are going to cover the Doppler effect for the source moving and the observer moving, and some examples as well. So on this first slide, we have a source that's moving, a fire truck. All right. We have observer 1 and observer 2. All right. The fire truck is moving away from observer 1 and towards observer 2. We see here in this diagram what's happened to the wavelength for observer 1. They're longer. Each time the wavelength is emitted, the truck moves away, okay, and then emits again. That added distance increases the wavelength. On the other end, you got observer 2. You got these short little wavelengths happening here. Every time the fire truck emits a wavefront, okay, it moves towards that wavefront and emits another one, okay? So that is pretty much what is happening here. So for observer 1, what is happening for them? Well, let's see here. There are fewer waves detected per second. So fewer wavefronts are detected per second. And additionally, there is going to be a lower frequency, all right, a lower pitch in terms of the sound, okay, and longer lambda. All right. What does observer 2 see? Observer 2, on the other hand, all right, is going to see more waves detected each second. All right, more of those wavefronts are going to be passing by them. Okay, just missed about a second there. And then, because of that, higher perceived frequency, okay, or higher frequency that they get, higher pitch, and a shorter lambda, okay? So, the truck, okay, is moving at constant velocity, all right? What we end up getting here is one constant high pitch, all right, moving towards, and one constant low pitch moving away, okay? So for a truck, at a constant V, we end up with one constant high pitch and one constant low pitch. All right, moving towards and moving away. So the truck speeding up we have a pitch increase if it's moving towards the observer. Pitch is going to decrease. So what you'll need to be able to do, all right, is on a test I'll be asking you to graph the frequency versus time, okay, of this happening. Okay, so for the constant velocity situation, okay, this is what we get. This is when we're moving towards. This is when we're moving away. This is if a truck is driving towards us and then passes us and keeps driving on. All right, and this is the shift in frequency that we would notice. So again, the equations here that you need to care about, all right, for moving source, the equation is f prime is equal to f, all right, times v all over v plus or minus u sub s. All right, f prime is the shifted frequency. F is the original frequency. V, speed of sound in the medium. All right, and U sub s is equal to the speed of the source. right? And remember, STS, source, sort, subtract. All right, to help you keep straight which is which. If the source is moving away, just add. Okay, a quick little example there. In your notes, we had a high-speed train traveling at 44.7 meters per second. All right, when the engineer hears the 415 hertz the engineer sounds the 450 hertz warning horn. The speed of sound in the air is 343 meters per second. What are the frequency and wavelength of the sound as perceived by a person standing at the crossing where the train is approaching? All right, so first things first here. All right, we deal with finding the. So let's write down all of our information here. Okay, speed of the source. 44.7 meters per second. Speed of the wave, sound in the air. Original frequency. What we're asking you to find is f prime and lambda prime. Alright, so let's see here. F prime, we can get from, and we're going to say that the train is approaching person standing at the crossing. All right, so we just add this. And since this is source moving towards, we're going to subtract. Okay. Alrighty. So we're going to take the difference between these speeds here and the new frequency. This can be 477 hertz. And then we can solve for the wavelength. And I think my sig figs here are awesome. I just go check my calculations. So remember sig figs in here. 3 divided by 7. All right. Okay. So that is an example of how the frequency and wavelength are going to change for a source that is moving. All right. So now we're going to take a similar look in the next video for an observer that is moving.